Here is an introduction to dot products. This video can be understood by students with algebra background only, but it is primarily intended for students who are taking physics with calculus. Here is the basic definition. If A and B are vectors, and theta is the angle between them, then the dot product is equal to the product of the magnitudes of A and B times the cosine of the angle between them. It is important to take note that the angle is meant to be between the vectors and not the angle of either vector with respect to the coordinate system you have set up. It is also important that the result of the calculation will give you a scalar result. This is despite that the input are two vectors. Here is a basic demonstration. Suppose you have two vector quantities A and B as given here. First, we need to recalculate for the angle between them. The angle in this case is 40 degrees. When we plug in the magnitudes and the angle between the vectors, we get about 15 Newton meters. You will see the physical relevance of this in the topic of calculating work. Note that the two vectors did not need to be the same type of quantity. In this case, A was a displacement and B was a force. Because the dot product depends on the relative direction of the vectors, vectors that are perpendicular to each other will result in a dot product of 0. Furthermore, the result of a dot product can be negative. This happens when the vectors have opposing components. Please refer to the topic on work to interpret this answer, as a negative sign on a scalar result does not mean a direction. If your vectors are given in component form, ijk representation, then the result will be the sum of the product of like components. Unlike components cancel out because they are perpendicular to each other. Here is an example of using dot product with vectors that are represented in component form. Notice that components can be zero or even negative. At the end, you need to take note of this when you sum up. In summary, please practice the definition of a dot product, keeping in mind that you need to recalculate for relative direction. Perpendicular vectors will result in a zero dot product if the vectors are opposing. The result can be negative, and if you are using dot products in component form, you still need to sum up the result at the end.